completion, the location of the ships, their headings, which one is most preferable?
Reduction speed only, sir.
Right, beta? So we are not bothered about maintaining the steerage way. Our priority here is collision avoidance. Okay. If required, if we are not able to maintain the steerage way, we will give a stern kick and stop then and there. Okay. Let the other
Okay,
two
understood.
vessels pass and then proceed ahead, beta.
Okay, sir, understood.
Okay. Steerage way doesn't come into the priority at all in this kind of a situation. Right, beta?
Okay, sir.
Right.
Yes, sir.
अब एक डाउट और था बेटा कि जो N1 वाला CPA पॉइंट है पापा नवंबर 1, वाई वी आर नॉट एबल टू अचीव दैट N1 CPA विद रिडक्शन इन स्पीड. अब बेटा आप यहाँ पे ध्यान से देखो, अगर आप अपने शिप को रोक भी दोगे, इवन इफ यू स्टॉप योर शिप, दैट मीन्स योर स्पीड हैज कम टू 0, even then target delta is going to pass forward of your bow, right? There is no way target delta can go on a line of approach of Papa November 2, right beta? So there is no possibility of reduction in speed to achieve a CPA of Papa November 1. So is that part clear now beta?
Okay, sir.
Questions involving multiple targets, more than one targets. So this very nearly corresponds to the practical situations which we face on board. We may have multiple targets close to us and we may be required to take action following the ROR. Now when we are having multiple targets, more than one targets, the main question or main doubt which arises is that our action should be basis which of the three targets, which of the two targets or three targets. So for that, in case of a close quarter situation developing with multiple targets, we follow the priority like this. In case of targets with different TCPA, that is the time for closest point of approach, the earlier occurrence poses a greater risk than the later one. So we check the TCPA of all the targets. The target having the minimum TCPA, which means earliest occurrence, that target poses the greater risk than the one whose TCPA is occurring at a later time. Now in case we have multiple targets with similar TCPA, both the targets or all three of the targets are having a similar TCPA, the one with a closer CPA poses a greater risk to us. Now once you find out or pinpoint the target which poses a greater risk, the target that poses a greater risk would require an action of greater magnitude. Hence, during evaluation, choose the action suitable for the greater risk target and then check this action suitability for other targets also. This will ensure that the vessel maintains its required CPA with all the targets which are there close to us. So with this, now let us proceed to few questions having multiple targets and see how do we solve them. So is this part clear beta? The priority, how the targets are to be prioritized?
Yes, sir.
Very good beta. Let's now go into some examples. So we have our next question on the screen now. The question says, own ship's course is 240 degrees true and speed of 15 knots. In restricted visibility, observes the following two targets, target C and D, target Charlie and target Delta. First observation is made at 1000 hours. The bearing of target C, target Charlie, is 314 degrees true and the range is 11.9 miles. For target delta, the bearing is 208.5 degrees true and the range is 10.0 miles. The next observation is taken after 12 minutes at 10:12. The bearing of target C Charlie remains 314 and the range is 8.3 miles. The bearing of target D Delta is 211 degrees true and the range is 5.1 nautical miles. We have to find the CPA range, CPA time, course, speed and aspect of these targets at 10:12. Master decides to take action at 10:16 to have a minimum CPA of 2 nautical miles. Evaluate the possible alternatives available to the master and explain which of them is most preferable. Now some important points from the question. First thing which we notice is that the ship is in a restricted visibility area. So we have rule number 19 in force. The second thing which we notice is target Charlie has its bearing as 314 at both the observations and the range is reducing. So the target Charlie is on a collision course. So the first part of question is exactly what we have done till now. So let us first plot these two targets and find out the CPA range, time, course, speed and aspect of both of them. Any doubt in the question, beta? Let us first have the plotting sheet. We have the plotting sheet on the screen now. Let's mark the center of the plotting sheet as C Charlie. Let's mention the scale which we will be using. The scale is 1 centimeter equal to 1 nautical mile. Let's now mark the course and speed of own ship. Own ship is steering 240. So you see the green color arrow coming up on the circumference of the plotting sheet at 240. Speed is 15 knots, so speed is also marked. Let us first plot the target C, target Charlie. The range is 11.9 miles and the bearing is 314. So on a bearing of 314 at a range of 11.9 miles as per our scale, we plot our first position and this position is applicable for 1000 hours. We mark the time along with the position and this is named as O, Oscar. Let's plot the second position. We have the second position here. The bearing remains the same, 314, and the range is now 8.3 miles. This observation is taken at 1012 hours and as per our system, the point is named as A, alpha. Now let's join the line OA and extend it. Oscar alpha line is joined and extended and this gives us the relative line of approach of target Charlie. We can see the relative line of approach is passing exactly from the center or from the own ship position, indicating that the target is on a collision course. Let us now plot own ship's course vector. So from point O in the reverse direction of our course, we mark off this green color vector O to W. Now WO represents own ship's course and distance steamed in the plotting interval of 12 minutes. Now if we join W with A, whiskey with alpha, WA vector gives us the course and the distance covered by the target within the plotting interval. So we have the WA vector representing the course and the distance covered by the target in the plotting interval from 1000 hours to 1012 hours. So the information what we obtain from plotting is target Charlie is on a collision course. We can also find out the time. The time can be found by measuring distance alpha to Charlie divided by Oscar to alpha multiplied by 12. So Oscar to alpha distance is covered by the target in 12 minutes. We find out how much time would the target take to come to Charlie, and that would give us the time to CPA. So we obtain from the plot target Charlie is on a collision course and the collision is predicted at 1040. The course of the target Charlie is 180 degrees true and the speed is 20 knots. WA distance has been covered by the target in 12 minutes. So interpolating for 1 hour, we get the speed as 20 knots. We also obtain the aspect. The aspect in this case is 46 degrees red. That means we are 46 degrees onto the port side of the target Charlie. So this is a basic radar plot beta. Any doubt coming in your mind up to here? Let us now plot our second target delta. For target delta, the first bearing is 208.5, range is 10 miles. So on a bearing of 208.5 at a range of 10 nautical miles, we plot the first relative position of target delta. This is applicable at 1000 hours and we name that position as O, Oscar. The second bearing is 211 degrees true. So at a bearing of 211, the range is 5.1 nautical miles. As per our scale, at a range of 5.1 nautical miles, we plot the second position of the target delta. This is taken, observation is taken at 1012 hours. And this position is named as alpha. Now we join Oscar to alpha and extend this line. Oscar to alpha line extended gives us the relative line of approach. Now from point Oscar, we mark our own ship course and distance in the reciprocal direction, in the reverse direction. You can see the green color vector coming up. The free end of the vector is named as W, whiskey. Whiskey to Oscar represents own ship's course and distance covered in the plotting interval of 12 minutes. Now if we join W to A, whiskey to alpha, this vector whiskey to alpha gives us the course and distance of target delta. So we can measure off the course and distance of the target delta from WA vector. So when we measure this information, obtain this information, we come to know that the CPA for target delta is 0.4 nautical miles. You can see this is the CPA here. You have to drop a perpendicular from Charlie to the relative line of approach. That will give you the CPA. The CPA is 0.4 miles and it is happening at 1024. Again, we can measure the distance between alpha to the CPA point. Now the ship has covered a distance of Oscar to alpha in a interval of 12 minutes. Interpolating for this distance, we can find out what is the time at which the CPA would occur. And in this case, the CPA time comes to 1024 hours. We can measure the course of the target by the direction of WA, and the course comes out to be 351 degrees true. We also know the target has covered a distance of whiskey to alpha in 12 minutes. So interpolating it for 1 hour, we get the speed of the target, which is 15 knots. We also find out the aspect of own ship. So the angle between the heading of the target vessel, and the bearing of our own ship from the target, that comes to 40 degrees and it is green because our ship falls on starboard side of the target. So first part of the question is done. We have plotted both the targets. We know their CPAs, DCPAs, the course and speed of the target is known, and the aspect is also known. So beta, any doubt coming to your mind up to here? Any of the three ships is free to take any action to avoid a close quarter situation. However, we can observe here that each ship has the other two ships forward of her beam. You can consider any particular ship. You can consider target Charlie. Both the other ship, own ship as well as target Delta, are forward of her beam. You can consider target Delta. Both our ship, own ship as well as target Charlie is forward of his beam. And you can consider own ship at Charlie. Both the ships, target Charlie as well as target Delta, are forward of our beam. Hence, as per rule 19, none of the three ships is permitted to alter course to port. So in view of this, own ship is having only two options which are available to the master. One is a alteration of course to starboard, and the second is reduction of speed. So we will now evaluate both these actions, and we will see which of them is most preferable and recommended in this situation. Now, how should we evaluate the action? Which target shall we take to evaluate the action? Should it be target Charlie or should it be target Delta? Now, if you have a look at CPA of both the targets, are indicating either a collision with target Charlie, and with target Delta, the CPA is very less, that is 0.4 miles. So there is no major difference in the CPA. But if you have a look at their TCPA, the time to closest point of approach, the TCPA for target Charlie is happening at 10:40, whereas for target Delta it is happening at 10:24. That is about 16 minutes before target Charlie. So since the CPA with Delta is happening 16 minutes earlier, we will take a action to have a CPA of 2 nautical miles or more for target Delta, because target Delta has the priority over target Charlie because of the frequent or earlier TCPA. So we will first evaluate our action basis target Delta, and then we will check this action for target Charlie. So is this part clear, beta? We have given priority to target Delta because it has a earlier CPA. Any doubts up to here?
Sir, अगर CPA में difference 1 or 2 minutes हो, still we consider Delta.
Now, since we need a CPA of 2 nautical miles, let us first plot this CPA circle, keeping our compass at the center of the plotting sheet at point C, point Charlie. I open up my compass equal to 2 nautical miles and draw my CPA circle. So we have our CPA circle. Now the question says that the action is to be taken at 1016 hours. So let us first predict the position of target Delta at 1016 hours. We know target Delta has moved from Oscar to Alpha in 12 minutes. So interpolating it for 4 minutes, we can obtain the location of target Delta, predicted position of target Delta at 1016. So you can see the predicted position P Papa coming up on the plot. Now from Papa, I draw a tangent to my CPA circle. You can see this tangent coming up. Now there are two possibilities for drawing the tangent. You can see the first possibility, Papa to November 1. The second possibility is on the other side of the CPA circle. You can see the second possibility now, Papa to November 2. So if our line of approach from point P, from point Papa, changes over to Papa November 1, we will have a 2-mile CPA. Or the other option is that if our line of approach changes over to Papa November 2, we will again have a 2 miles CPA. So is it clear up to here, beta?
No, sir.
Options which are available to us, CPA can occur at November 1 or November 2. So let us evaluate these two options one by one. So what we do first is we pick up the line of approach Papa November 1. We align our parallel ruler to this particular line, take our parallel ruler to point alpha and draw a line parallel to our new relative line of approach, that is Papa November 1. So you can see this line coming up on the plot. Now what I do is I open up my compass equal to WO, Whiskey Oscar, for target delta. Center my compass at point W, Whiskey point, and draw an arc. You can see this red color arc coming up on the plot. The arc is centered at Whiskey and the radius is equal to Whiskey Oscar. Now this arc intersects our new relative line of approach at this particular point. So let us name this particular point as Oscar 1. Now we join W to Oscar 1. You can see the W to Oscar 1 vector coming up. Now this W to Oscar 1 gives us our first option. If the ownership course becomes W Oscar 1, then the triangle which we will have will be W Oscar 1A. The relative line of approach will become O1A, and effective at 1016 hours, that is at point Papa, this relative line of approach will take the target on Papa November 1 track, and when it reaches at November 1, it will have a CPA of minimum 2 nautical mile. Now we align our parallel ruler or set square or sliding ruler to W Oscar 1 and measure this course using the plotting sheet as a compass rose. We measure the course and this comes to a course of 317 degrees true. 317 degrees true. So if ownership alters course to 317 degrees true, initial course is 240, so that's an alteration of 77 degrees to starboard. If our ship alters course to 317 degrees true, effective at 1016, the target will have a CPA of 2 nautical mile at point November 1. So let me know your doubts up to here, beta. Now let us evaluate the effectiveness of this action for target Charlie also. So what I do is at point Whiskey, now I draw my new course. My new course would be 317 degrees true. So you can see this green color vector coming up. And let us name this as O1, this point, the free end of the vector. Now if I join O1 with A, this is going to give me the new relative line of approach for target Charlie. So the length of WO1 is exactly same as WO. There is no change in our speed. So this is indicated by this arc also here. Now we join Oscar 1 to alpha. This will be our new relative line of approach. Since this is effective at 10:16, so let us first predict the position of target Charlie at 1016 hours after 4 minutes. So interpolating this difference, the distance Oscar to alpha is covered by target Charlie in 12 minutes. Interpolating, we obtain the predicted position of target Charlie at point P here. Now we transfer the new line of approach, that is Oscar 1 alpha to point P. So you can see a line parallel to Oscar 1 alpha coming at point P. This will be the new relative line of approach for target Charlie. You can see 3 arrows coming up. 3 arrows can be shown to predict the new relative line of approach after a action is taken. Now our CPA will be occurring at this particular point, November 1 here. You can drop a perpendicular from Charlie to this new relative line of approach for target C, and this meets here at November 1 point. And it tells us that the CPA for target Charlie will be more than our required value of 2 nautical miles. So this indicates that this action of alteration of course to 317 degrees true will make the CPA of both the targets more than our required CPA of 2 nautical miles. So this is the first option which is available to us. Let me know your doubts up to here, beta. Now let's see the second option. The second line of approach which we had, the second option was Papa November 2. Papa November 2. So we can now draw this second line of approach, Papa November 2, from point alpha. So I align my parallel ruler to Papa November 2, take it to point alpha, and draw a parallel line. So you can see this parallel line coming up here. This is for target delta. So this can be the second option for our relative line of approach. Now this new relative line of approach from point alpha intersects our WO vector. WO vector, it intersects at this particular point, and let us name this point as O2. So now you see, if our speed is reduced so that in 12 minutes we do not cover a distance of WO, but instead we cover a distance of WO2. You can see this WO2 vector. If we cover a distance of WO2 by reducing our speed in 12 minutes, our triangle would be WO2 alpha. And in this case, O2 alpha would become our relative line of approach. Transferring this approach to point P, that is 1016 hours, we will have the line of approach like this. The line of approach will take the target ship delta at its CPA at point N2. So again, target delta will have its CPA at point N2, November 2. Now we measure this distance WO2. This distance has to be covered in 12 minutes. We interpolate for this for a period of 1 hour, and that gives us our new speed. And the new speed of our ship comes to 2 knots. So if we reduce the own ship speed to 2 knots, WO2 will be the own ship vector, O2A will be the relative line of approach, effective at 1016, that is at point P. This will take the target to Papa November 2 line of approach. CPA would occur at November 2, and it will be 2 nautical miles. So have a good look at the second option which is available to us. Let us now check the effectiveness of the second option, that is reduction in speed for target Charlie. So let's do that. Our initial own ship vector was Whiskey to Oscar, WO. Now we modify the length of this vector as per our new speed of 2 knots. And this is modified now to WO2 here. You can follow the laser pointer, W2O2. This is the new own ship vector. Now from O2, I join a line with point alpha. You can see Oscar 2 to alpha dotted line coming up. This will be the new relative line of approach for target Charlie. This is effective at 1016 hours. So transferring this line O2 alpha at point P, which is the predicted position at 1016, we have our new line of approach. So you can see this dotted line from point Papa of target Charlie showing up on the screen, and we can clearly see that the CPA of target Charlie has increased from its initial value. So it is much more than 2 nautical mile, which is the required CPA. So we have now seen that this is the second option which is available to us. Reduction of speed. If we reduce the speed to 2 knots, both the ships will have a minimum CPA of 2 nautical miles. So any doubts up to here? With a third option which can be picked up from this diagram. The third option which is available to us is an alteration of course to port. So you see here, this was our initial course vector for target delta. You can follow the laser pointer. For target delta, our ship course and distance vector was W Oscar. Now if instead of W Oscar, if we steer a course of W to this particular point here, O3, you see this is the arc which we had drawn representing our distance in 12 nautical miles, and this was the line of approach, Papa November 2 line of approach drawn at point A. They were intersecting at this particular point. We name it as O3. So if own ship alters course to WO3, then WO3A would become our new triangle. O3A would be the new relative line of approach. Effective at 1016, that means at point Papa, this relative line of approach would take the target on Papa November 2 track, and it will have a CPA of 2 nautical miles. This option is also available as per radar plotting, but this option is prohibited by ROR Rule 19. Any alteration of course to port is prohibited. So we cannot take this option. WO3 option is not allowed. Is alteration of course to starboard. Now own ship course is 202 degrees true. Speed is 6 knots. In restricted visibility, own ship is capable of doing 14 knots, and we observe 2 targets, target A and target B. Target A is observed at 0700 hours, bearing is 029.5 degrees true, range is 5 nautical miles. The second observation is taken at 724. The bearing is 024 degrees true and the range is 3.8 miles. Target B is observed at 0706, bearing 315, range is 11 miles. And again, the next observation is made at 0730, the bearing is 315 and range is 7.7 miles. Analyze the situation at 0730 and state with reasons what would be the most suitable action to take to have a minimum CPA of 2.5 miles. So we can see in the question, it is again set up in a restricted visibility scenario. Second thing we observe is the vessel is moving at a slower speed. It is capable of doing 14 knots, but is right now moving at a speed of 6 knots. This must be the safe speed as ascertained by the master in that situation. The third thing which we notice is the plotting time for both the targets are different. For target A, the observation was taken at 0700 and the next one 724. For target B, the observation was taken at 0706 and 0730. So let us now see how do we go forward ahead with this question. Let us first open up the radar plotting sheet. You can see the radar plotting sheet coming up. I have only shown the relevant portion of the plotting screen so that we can zoom into the working and understand it better. Let us mark as usual the center of the screen as Charlie. Let us show our scale which we will be using. So we are using a scale of 1 centimeter is equal to 1 nautical mile. Let us also show the course of the ship. You can see this green color vector showing the course of 202 and we are moving at a speed of 6 knots. This is to be shown at the circumference, but since the bottom part of the plotting sheet is not there, I have shown it here itself. Let us now plot the targets one by one. We first plot target A. The first bearing is 0 to 9.5. This is the first bearing and the range is 5 nautical miles. So on a bearing of 0 to 9.5 at a range of 5 nautical miles, we have the first relative position of the ship. This is observation is taken at 0700. We indicate the time. The position is represented by O Oscar. Let's plot the second position now. Bearing 0 to 4, range is 3.8 miles. Observation is taken at 0724 hours and this relative position is named as Alpha A. We have the Oscar Alpha, both the positions plotted now. Let us join them and extend the line. You can see the OA line, Oscar Alpha line extended. This is the relative line of approach. We mark it with double arrows. And from this relative line of approach, we can now, if we drop a perpendicular from the center to this OA line extended, we can find out the CPA. We can find out the CPA range as well as the CPA time. Now, the last observation for target A was taken at 724. The action is to be taken at 0730 hours. So let us also predict the position at 0730. We know the target has moved from Oscar to Alpha in 24 minutes. So interpolating for another 6 minutes, we get to the location at 0730 represented by point P, Papa. So point P, Papa is the predicted position of target A at 0730 hours. Now from point O, we draw own ship course in the reverse direction. So our course was 202. So you can see this green color line coming up in the reverse direction of own course. The free end of this line is named as W, Whiskey. And we know Whiskey to Oscar represents the course of the ship and the distance covered in the plotting interval. The plotting interval is 24 minutes. Now we join W to A, Whiskey to Alpha, and we know Whiskey to Alpha vector, the maroon color vector, represents the target's course and distance covered within the plotting interval. So we have the target's course and distance. Distance can be interpolated. This distance is covered by the target in 24 minutes. Interpolating for 60 minutes gives us the speed of the target. So once we measure these things, we get the CPA of target A as 1.45 miles. The CPA is happening at 0829 hours. The course of the target is 210 degrees true and the speed is 9 knots and the aspect at 0730 hours is 9 degrees red. So all the items have been calculated for target A. So up to here, okay, beta? No, that's 0730, right? That's 0730. So all the items for 0724 hours have been calculated. Now let's plot the second target. So target B. Target B first observation is taken at 0706, bearing 315, range 11 miles. So 315 bearing, range 11 miles. We have the first relative position of the target coming up on the screen. The observation is taken at 0706, so we can see the time coming up. We mark this observation position, relative position, as O Oscar. Next observation is taken at 7:30, bearing remains the same, 315, and range is 7.7 miles now. So we show the time along with this relative position as 0730, and we represent this relative position as A alpha. Now we join the line Oscar alpha and extend it further to get our relative line of approach. Mark with double arrows. This is the relative line of approach, and we come to know that the target is on a collision course. Now from point O, we mark off the own ship course in the reverse direction, reciprocal direction. Our course is 202. You can see this green color vector coming up in the reciprocal direction. The free end is named as W Whiskey, and we know Whiskey to Oscar is the own ship course and distance vector for the plotting interval. Now we join W with A Whiskey with alpha, and we know Whiskey alpha vector is the target's course and distance covered in the plotting interval. Now, so up to here clear beta. The target B, the data is available to us. For target B, the collision is expected to occur at 0826 hours. The course of the target ship, represented by vector Whiskey alpha, is 163 degrees true. The speed is 12 knots and the aspect is 28 degrees red. Now let us see our involvement with both these targets. Let us first have a look at target A. If you look closely, target A is overtaking own ship. Own ship is moving on a course of 202 degrees with a speed of 6 knots. The target ship is moving on a course of 210 degrees with a speed of 9 knots. So own ship is being overtaken by target alpha. But in this particular situation, the rule 13 overtaking rule is not applicable. What is applicable here is rule 19, because the question is set up in a restricted visibility scenario. Vessels are not in sight of one another and rule 19 is applicable. Now at the moment there is no risk of collision if both the ships maintain their course and speed. However, if own ship takes action after 7:30 to pass clear of the other ship, target B, then in this scenario, whatever action we take, as per rule 19, we should avoid an alteration of course to starboard. We should avoid an alteration of course to starboard, as this action contravenes or is in contradiction or against Rule 19D of ROR. So alteration of course to starboard should be avoided. Rule 19 says vessel should not alter course towards a vessel abaft her beam. Now the second action which could be possible, which is a reduction in speed of own ship. Now in this particular scenario, as far as target A is concerned, a reduction of speed should also be avoided, because a reduction of speed would result in becoming the CPA becoming lesser, and it may lead to a close quarter situation with target A. So we should avoid an alteration to starboard, and we should also avoid a reduction of speed. Alteration to starboard contravenes Rule 19, and a reduction of speed may lead to a close quarter situation happening with target A. Now let us move our attention to the target B, target Bravo. Now target Bravo and own ship are on collision courses. Own ship is being overtaken from the starboard quarter by target B. So you can see own ship is steering a course of 202 degrees with a speed of 6 knots. The target ship is steering a course of 163 with a speed of 12 knots. So own ship is being overtaken from the starboard quarter by target B. And again, if you analyze the situation with target B, own ship should avoid alteration of course to starboard, because a alteration to starboard would be in contravention or it will contradict Rule 19D of ROR. So with this understanding with both the targets now, Alpha and Bravo, let us now evaluate what all possible actions are available to us which should be taken to have a CPA of 2.5 miles. So one possibility which has already been rejected is the reduction of speed. Reduction of speed should not be done. It may lead to a close quarter situation with target A. The second possibility, there could be an increase of speed also in this case. Vessel is right now doing 6 knots, but it is capable of doing 14 knots. But the increase of speed is inadvisable, because in this restricted visibility scenario, the master considers it to be safe, consider the 6 knot speed which the ship is doing to be the safe speed under these circumstances, and any increase in speed would mean that you are moving at a speed greater than the safe speed as ascertained by the master. So an increase of speed should also not be done in this situation. Then another action which we had evaluated is starboard alteration. Starboard alteration is prohibited by ROR, Rule 19. And the last option which is available to us is a port alteration. So let us now evaluate if we do a port alteration, how does the situation with both these ships changes. So let us now try to visualize if the vessel alters course to port to maintain a CPA, minimum CPA of 2.5 nautical mile, what would be the action required? What should be the alteration required? So for this, let us open up our compass equal to 2.5 miles as per our scale. Center our compass at the center of the radar plotting screen at point Charlie, and let us now draw our CPA circle. So you see the CPA circle of 2.5 miles coming up on the plot. Now what I do is Out of these two targets, target A and target B, if we have a look at their TCPAs, target A is happening at 0829, target B is happening at 0826, which is very close, almost happening at the same time. Now let us have a look at their CPA. CPA of target A is 1.45 miles, whereas for target B, the CPA is 0. Target B is on a collision course. So for our action, we will give the priority to target B. Target B is having 0 CPA, so we will give our priority for action taken to target Bravo. So what I do now is 7:30 position of target Bravo, that is point A alpha. I draw a tangent to my CPA circle. You can see this dotted line coming up. So to maintain a CPA of 2.5 miles, this should be the line of approach for target Bravo. I extend this dotted line backwards from A, and we see it cuts off our so we extend this dotted line in reverse direction from target A, and if the vessel follows this dotted line as the line of approach from 7:30 onwards, the CPA would occur at point N1, November 1, and you can see the requirement of 2.5 miles minimum CPA will be maintained. Now we want to have a alteration of course to port to achieve this CPA. So what we do now is we open up our compass equal to distance WO, Whiskey Oscar. This is the distance covered by own ship in the plotting interval of 24 minutes. Since there is no change in speed, we will be doing this much distance. So we open up our compass, radius equal to WO, Whiskey Oscar. We center our compass at point W, Whiskey Point, and we draw an arc. You can see this red color arc coming up on the plot. Now this red color arc cuts our new relative line of approach, that is the dotted line at this particular point here. You can follow the laser pointer. This is the point where the arc cuts the new line of approach. Let us name this point as Oscar 1. W Oscar 1. You can see this W Oscar 1 line coming up on the plot. This W Oscar 1 should be our new course to steer. So you see we have not made any difference in the distance covered by own ship in the plotting interval. WO and WO1 are exactly same distances. They are the radius of the same circle. There is no change in speed of own ship, but there is a alteration of course. Initially, if the ship was steering Whiskey Oscar course, now the ship is steering Whiskey Oscar 1 course. So there is a alteration of course to port. Now if our ship steers course WO1, Whiskey Oscar 1, then the triangle which is formed for target B will be W Oscar 1 alpha. You can see this particular triangle W Oscar 1 alpha. This will be the triangle formed, and Oscar 1 alpha will become the relative line of approach, maintaining a CPA of 2.5 nautical miles from own ship at point November 1. Now we can align our parallel ruler to Whiskey Oscar 1. Observe that the alteration of course which is required is 30 degrees. 30 degrees to port. And the new course which we obtained is 172 degrees. So you see, initial course was 202 degrees. Now we have 172 degrees, the course to be steered, a alteration of course to port by 30 degrees. So if our own ship alters course to port by 30 degrees, we will have a minimum CPA of 2.5 miles with target Bravo. So beta, any doubts up to here?
No, sir.
Okay, great. Now let us check the effectiveness of this action for target alpha. So what we do now is we take our compass to whiskey point of target alpha. You can follow the laser pointer. So the compass is open to a radius equal to whiskey Oscar. That is the distance covered by own ship in the plotting interval of 24 minutes. Compass is centered at point whiskey, radius equal to WO whiskey Oscar. We now draw an arc, and on this arc now we draw our new course of 172 degrees. You can see this new course of 172 degrees coming up. Whiskey Oscar 1, WO1 represents our new course to be steered. Now if we join Oscar 1 with alpha, this will give us the new relative line of approach for target alpha. So you see this Oscar 1 alpha dotted line coming up. This is the relative line of approach, and this action is to be taken at 7:30. So effective at 7:30, that means at point Papa here, if we have this relative line of approach, we can now draw a line parallel to Oscar 1 alpha passing from point Papa. Let us have that line on the plot. You can see the new relative line of approach coming up for target alpha, and you can see that the CPA with target alpha has also increased. Initially the CPA was less than 2 miles. It was coming within the circle. It was 1.45 miles. But now you see with the new relative line of approach, that is the dotted line, the new CPA with target alpha has also increased more than 2.5 nautical miles. So port alteration is the best action to take under these conditions. An alteration of 30 degrees to port has given us a CPA range of target A and target B as 2.6 miles and 2.5 miles. We have a CPA with target B of 2.5 miles, and with target A we have a CPA of 2.6 miles. So this completes our plot. Alpha is basically overtaking us. So it is more or less almost at right astern. Okay. So it is overtaking us, and it is going to overtake us from our starboard quarter. You can see the line of approach. Now in this case, if you reduce your speed, you see you will be entering into a close quarter situation with target alpha. Target alpha is moving at a much faster speed. Okay. So target alpha is moving at a speed of 9 knots, whereas you are moving at a speed of only 6 knots. Okay, so once you have this, I think you will be able to appreciate now that reduction in speed is going to put you in a danger situation with target A.